The humble beginnings of space propulsion stretches all the way back to around 400 BC. A Greek man who once lived in a city in southern Italy amazed citizens with a wooden pigeon. The pigeon was attached to wires and flew across them utilizing escaping steam as a method of propulsion. This is one of the first devices that successfully applied principles necessary for rocket flight. The first true rockets were believed to have been developed by the Chinese. The Chinese supposedly had access to a rudimentary gunpowder made up of sulfur, charcoal dust, and saltpeter. By filling bamboo tubes with the mixture and throwing them into fires, they were able to create small explosions for religious festivals. The Chinese experimented with the gunpowder and eventually attached the bamboo tubes to arrows and launched them with bows. Soon, they realized that the gunpowder tubes were able to launch themselves. The power produced by the escaping gases of the explosion were enough to propel the arrow through the air. Thus, the true rocket was born. The age of modern rocketry did not begin until around the 1900s. Robert H. Goddard experimented first with various solid types of fuels, measuring the exhaust velocities. He became convinced that they could be more efficiently powered with liquid fuels. However, the liquid-powered rocket would also require fuel and oxygen tanks, turbines, and combustion chambers. Goddard achieved the first rocket flight utilizing a liquid propellant on March 16, 1926. The rocket was fueled by gasoline and liquid oxygen and flew up for only 2.5 seconds. It climbed 12.5 meters and landed 56 meters away. The flight was rather unimpressive compared to today's standards, but the flight of the first liquid propellant rocket opened a new door for the future, and eventually it would lead us into space with the invention of the V-2 rocket. The first V-2 rocket was developed in 1936. Developed by the Germans and known as the A-4 to them, the V-2 rocket was small compared to modern rockets. The rocket utilized a 74% ethanol-water mixture as fuel and liquid oxygen as an oxidizer. An incredible thrust was generated by burning the mixture at a rate of about 1 ton every 7 seconds. In 1944, the V-2 rocket became the first man-made object to reach outer space. While there is no true space boundary, the generally accepted beginning of space is at 100 kilometers, also known as the Kármán line. The first artificial satellite, named Sputnik, was launched in the orbit around Earth by the Soviet Union in 1957. The satellite was launched with the R-7 Semyorka rocket, which utilized a kerosene-based fuel and liquid oxygen as an oxidizer. Both Sputnik 2 and 3 were launched also using liquid oxygen and a highly reformed kerosene fuel. The U.S. launched their first satellite, Explorer 1, in 1958, launched by the rocket Juno 1. It used hydine as fuel for the first stage of the launch. The other 3 stages of the launch used a solid fuel, polysulfide aluminum and ammonium perchlorate. While the usage of rockets has remained generally unchanged over the decades, scientists now search for methods of sending spacecrafts to other planets and systems. The first spacecraft to reach another planet was the Mariner 2, which did a flyby of Venus on December 14, 1962. The Mariner 2 was equipped with a retro-rocket, an engine that provides thrust opposite the direction of the vehicle for mid-course maneuvers. A modern-day and more advanced spacecraft is the Dawn spacecraft, launched in 2007. The purpose of the mission was to visit 2 large bodies in the asteroid belt, as well as to test out its ion drive technology in deep space. The spacecraft is propelled by 3 xenon ion thrusters. The ion thrusters create thrust by accelerating ions with electricity, in this case, xenon ions. The thrust generated is usually extremely low, so the craft takes a long time to pick up speed. However, the ion thrusters can deliver 10 times as much thrust per kilogram of fuel than a chemical rocket, and is therefore very useful for long-term missions, such as the Dawn's mission. The future of space propulsion is still up for huge speculation. One possibility for the future of space travel is the use of solar sails. The idea is to send a spacecraft that will unfold a giant sail in space. The sail, coated with highly reflective aluminum, would work by catching particles of light called photons. The photons carry momentum, and the idea is that by catching enough of them, you can reach high speeds without the use of any fuel. Unfortunately, the method would become less reliable when traveling to other star systems away from the Sun. Breakthrough Starshot is a program currently using this exact idea to send a nano spacecraft to the nearest star system, Alpha Centauri, within a generation. The miniature spacecraft would be launched into space and then unfold its solar sails. By launching powerful lasers at the sail, it is theorized that the tiny craft could reach up to 20% of the speed of light. Unfortunately, it is still entirely unknown how humans could travel to other stars efficiently. To do so, we would have to find a feasible way around the speed of light limitation. Some theorize that by bending space-time with a powerful enough force, you could ride through a bubble of sorts that would carry your spacecraft to another system in staggering times. Some even theorize that with the use of wormholes, future spacecraft could take a direct route through space-time to travel incredible distances. The idea would be similar to folding a piece of paper, which would be the universe, and poking a hole through the folded sides, which would be the wormhole. Then, the craft would travel through that hole to the other side. It is unknown if either of these approaches are plausible, and only time will tell where the future advancement of space travel will lead us.